Raise some
Cain. You gotta raise some Cain. In the heartland where the faith runs strong, we've seen the shadows growing long. Watch those around us be deceived. Yeah, the fight is at our doors, no matter who we believe. Corruption, lawless day and night, we'll speak the truth into the light. We'll bring the battle, heed the call, watch the whole thing fall. We gotta raise some Cain, show the lies, break some chains and make things right. Feel the power, be the change, time is now. We gotta raise some Cain.
Welcome to the Raising Cain Show, folks. We've got a special night tonight. You know, I like to mix it up. Oftentimes I do shows on politics or on national security, and this time around, I'm going back to something that I always love doing, which is scientific inquiry. And boy, do we have a great guest tonight, Dr. Weiping Yu. And so we're going to get into some really interesting stuff. He is a physicist at NASA's Kennedy Space Center. And I'm going to run to a commercial break first, get that out of the way so we don't have any interruptions. And when we come back, I'm going to introduce you guys to Dr. Yu, and we're going to get into some really awesome stuff, things about gravity, black holes, dark matter, and even the very structure of space and time. So be prepared, because tonight is going to blow your mind. We will be right back after a short commercial break, and I'll see you in a couple minutes.
It says, I woke up this morning and looked out the door to a country I don't recognize. They put masks on our face to hide our pain, and there's no fire in most people's eyes. And it's still true today. It's still true today that they've tried to destroy the American spirit. And in some instances, they've done a dadgum good job. But in other instances, they have lit an inferno in some people. And we right now are gathering some of those people that are on freaking fire to save this country.
Increasing expenses have caused us all a lot of pressure these days, and it's affecting even the wealthiest of people. Most have lost their sense of security, stability, and even hope for a strong financial future. The game plan of everyone in your cell phone has likely been disrupted or even hardcore stopped, and most are looking for a creative solution to regain financial momentum. Oftentimes, life's best solutions are the simplest. But first, a question. What is something most people think they should own but don't? Crypto, fine art, real estate? Nope. We are talking about real money. The kind kings and queens fought for and large institutions today buy in mass. We're talking about gold and silver, assets that provide confidence in tough financial situations. So the question is, do you own any? If you don't, you're not alone. Most people aren't maximizing the power of precious metals because it's just been too complicated. And even though they see advertisements about gold and silver daily, they don't really know who to trust. That is, until now. The bottom line is that buying gold and silver doesn't have to be complicated or scary. There's a simple, better way to accumulate assets and create financial peace, headache-free. And this very minute, a new community of average people are seeing above-average results to the tune of tens of millions in assets over the last few years. This system is tested, it's simple, And it's not an experiment. To date, it's helped more than 80,000 people bring hope back into their lives. It's invitation only. And right now, this new community has accepted a challenge to give away as much free gold this year as possible. Curious? Learn how to get your free gold today. Check out the next step to get the details.
Welcome to Shop with America, where the emphasis is on America. Our movement is to switch away from your shopping with the big box stores and the mega corporations back to supporting family-owned, made in America. We've been giving these big box stores our money every day for years. But what's happened is they've forced many small businesses to shut down. We call this the illusion of choice. We see all these products in these stores, but in reality, it's only a few companies that control it all. There are thousands of lawsuits for health damage because they put profit over our people. But there is another choice. We found a better way. There's a family-owned American factory with product integrity and have always done things the right way for the right reasons. And this company outperforms the big box stores. That's due to their month-to-month shopping club. They make everyday consumer products that we all use and buy again and again, like toothpaste, shampoo, coffee, and organic beef. Go to shopwithamerica.us today.
Welcome back to the Raising Cain Show, and I want to welcome a man who is shaking the very foundations of modern science, Dr. Weiping Yu, a physicist at NASA's Kennedy Space Center and the mind behind the universal particle theory. Dr. Yu has spent decades challenging what we think, what we know about the universe. He says gravity, black holes, dark matter, even the very structure of space and time are misunderstood. His bold claims have made waves across the scientific community, and now he's here to speak directly to you. So get ready for an episode that's going to challenge your brain, your beliefs, and possibility, your understanding of reality itself. Dr. Yu, thank you so much for joining the show today.
Thank you for having me today.
So, I am excited about this topic, and I'll tell you why. Years ago, I was driving 2 hours each way to work, and 2 hours to work and 2 hours back home, and I had a lot of time on my hand, and I took a course that was basically it was a theory of relativity, and it was a college university program that they had on cassette tape. That's how long ago it was. And I was listening to that on my way to basically on my way to work and back. And I had this phenomenon happen where at some point, what the professor was talking about all of a sudden clicked and made sense. And I had a panic attack. I had to pull over my car because my concept of reality began to shift as I thought about the fact that time and space were only relevant to how fast we were traveling according to the speed of light. So it was one of those kind of epiphany moments that made me realize that our perception of reality is really based on where we are right now on the planet. And it has nothing to do with reality outside of this planet when we were out in space. And it was the moment where the professor was talking about the Einstein talking about how if you had two sisters that were identical twins and one got on a spaceship traveling at 99% the speed of light to the nearest star and then came back, how they would be different in age. And so I'm really curious to hear what you have to say tonight. So I want to just kind of start with that story, because I think these topics, they're kind of scary for a lot of people, because it does challenge reality and it challenges what we perceive day in and day out. So what are your thoughts on this information that you're going to bring forward and its ability to challenge our perception of reality?
Today my focus will be on black hole. That's the major topic, right? But you are welcome to ask any questions offhand, or audience, any questions I will answer to you. The reason I feel like what I have been discovered over decades, over a decade ago, and I believe it will fundamentally simplify our understanding the real universe. And by it's simplified but not simpler, but I believe so, and make our understanding of the universe and to be logical and conventional and logical and without any incoherence be within the theory. And also I believe once you understand that we can improve the universe, say bring energies and make a lot of innovations based on the understanding. And I think this is unlimited, medicine, biology, and chemistry in particular. Physics, the main application is serving for the chemistry. And however, the current physics theory almost have nothing to do or counterintuitive to chemists. So I try to provide this my understanding. I hope make universe is more efficient and more truthful to individuals.
Well, you deal with the issue of black holes, gravity, and is it pronounced Uon Theory? I know
yes,
it's
Uon.
Okay. The Uon Theory. What exactly is the Uon Theory, and how does it differ from traditional physics?
Very good question. So Uon, this word Uon represents the fundamental particle. In this theory, we try to unify all the physical natural phenomena by one particle, one force, one field, one principle, and one universe. Without introduce anything like what is a relative space or relative time, multi dimensions, in some high dimensions, or multiverse. And I believe the universe is very simple. So that's why I started with what is the fundamental particle, which we all know instead of the particles discovered in the laboratory. I don't believe that's the fundamental particle.
So what is the fundamental particle in your opinion?
The fundamental particle, simple way to say, is magnetic particle. So I made a magnetic particle is at the fundamental level because in order to qualify fundamental particle, you have to be able to preserve its physical properties. A particle has to preserve its physical properties, right? Mm-hmm. And allow it infinitely subdivide, because we know anything we have, it always have a mass, have a volume or something, right? If you have any physical quantities, theoretically or hypothetically, you can always subdivide.
So if your theory challenges a lot of the things out there, I've read about string theory, for example, or membrane theory and multiverses and all of this kind of stuff. And of course, there's a big problem that for those that are watching the show right now that may not be familiar with these topics, there's a big problem between unifying quantum physics versus astrophysics and finding that divide. So does your theory, does it bring balance to those two?
Yes, it bring back, it basically bridge the relativity. We are talking about gravity, right? Mm-hmm. The microscopic, the universe scaled, the star galaxy scaled, matters with the smallest fundamental matters, electron or proton, electron, or even smaller particles. We try to unify all of them. Use one particle, one force, one principle, and all these are known to people. I believe above 3 years. So you have any education, kindergarten or above.
Yeah. Now you've said that black holes might not even exist.
Yes.
So what do you mean by that?
Oh, yeah, so yeah, now let's go to the topic is a black hole. If you can, I don't know if you can share a couple slides
Oh, yeah,
with,
let me bring up the
with
slides.
that one. So, because I believe one picture equals to thousands of words, right? So
Yeah.
this is basically the mystery of black hole explained by Uon Theory of everything. I hope to the end of today, and you should all understand what black hole really is. Okay, so
All right.
now let's go to next page if you can. And I'm gonna say, hey, I just want to give you a little, visual image about what is the black hole looks like on paper, right? So that's what I say. We have, at the center. We said at the center of a galaxy, we have called the singularity point. So yeah, we have a black hole. Let's talk about this one. And the black hole has a boundary, which we call the event horizon. So-called the event horizon, means that's the edge of a black hole. Beyond that, even light, even light cannot, escape.
Escape it, right.
Yeah, so that's a point of no return. So basically say, in the current theory is in any center of the galaxies, we should have reside one, such a black hole. Its physical property will be have enormous gravities, and so that's why even at the beyond the horizon, even light cannot go back. So that's why you cannot emit any light, and so that's why it looks black. So this is a basic image of black hole. If you wanted to know, so today I wanted to introduce two black hole theories. One is the existing. I believe that's a fake black hole theory. Okay. And I will explain why this black hole, just like on screen, is a fake one, and then I will introduce what is the true. I believe that's a real one. It's my opinion, and I want your audience to judge. So right now, the fake one, I believe that's the most popular one. Show black hole. You have a singularity point at the center, and you have an event horizon, which define basically the boundary of the black hole. So the first, you can ask questions, and then I will explain.
Okay. So on this theory, right? My understanding of the way that black holes have traditionally been taught is that they are such a large amount of mass.
Yes.
That it ends up warping space and time, and light can't escape from it. And the idea that I've seen proposed by many is that what goes into a black hole comes out of a white hole somewhere in some other verse or something like that, and that these things exist. But again, no one's ever been up close to one. So now my understanding is that in places like CERN and other hadron colliders, they've been trying to create black holes. Have they had any success in that? And does it confirm any of the theories that have been proposed thus far?
No, they never had to create a black hole in experiment, even at CERN, and I don't believe they will ever can create a black hole based on the current theory. So I wanted to talk about why I think this explanation, this theory is a fake theory. First, how do we get the black hole theoretically? So the first of all, we started with Einstein's general relativity. So we have a general framework describe how gravity works, right? However, the solution, was the first called the concrete exact solution was derived by Schwarzschild solution in 1916. Based on that solution, there's Penrose and Huygens work, and confirm that there is such an object, which is with a finite mass, however, almost zero volume. So that means if you calculate the density, so if any finite number divided by zero, it becomes infinite. So you have infinite dense of matter. So that's why you create an infinite strength, of force. That's gravity. So that's the concept of singularity point is purely from the theoretical equation, which has a singularity at divide by zero. Okay, so this is theoretically come out predict there's a possibility to have a black hole. However, there are some observations. So number one, based on the solar system, right? We find that everything rotating with a center of mass in the solar system, that's the sun, right? So people extended this concept. So, and observe at the center of a galaxy. The closest one is our own Milky Way galaxy. They do find, after like 20 years of research, they do find at the center of a galaxy, there are like it's called like an event horizon. Have edges, and they find out that there's those star system near the center rotate or revolute, very, very fast beyond any observed matter. So once they use a gravity equation to calculate, they said we're missing matter because we account all possible matters and we do not have enough gravity force to hold the star system nearby the event horizon, the edge of them, to hold them together. So that's why we say, hey, we're missing matter. So that's why.
Is that where dark matter, the theory of dark matter came from? Because they were missing matter?
Dark matter comes from the edge of a spiral galaxy. They find that on the edge of a spiral galaxy is rotating too faster than whatever mass we have. So that's why that's a dark matter proposal. It is missing matter. Black hole is based on near the center of the galaxy. Those stars rotate super fast. So that means, dark matter, we thought, hey, we're missing dark matter only through 5 to 10 times of visible matter, right? But at the center of black hole, so then the black hole could be billions the size of the solar mass. So that means the same concept. If we understand why missing matter for black hole, it will be similar logic to why we see missing matter for the dark matter for galaxy, to hold them together.
Now, I've always wondered because, I look at nature and I see certain patterns, and we know that electrons, for example, rotate around an atom. Is that force similar to the force that you propose is what holds everything together at the astrophysics size of things, or is it a different force?
If we're talking about the same force, we are talking about, let's say, electromagnetic force. Is that right?
Yeah.
However, you said, so we observed the electron orbit the nucleus, right?
Right. Yeah, nucleus, yes.
Actually, that's the part I discovered. There are no free orbiting of electrons along with so-called nucleus in an atom.
Oh, wow.
I discovered that's just impossible. If you assuming there's a constant rotational motion, right, orbiting motion around the center of a nucleus, that would make every atom is a perpetual motion machine. You know that, right? All the physics think about it. There are no perpetual motion machine. Something constantly running. And the running in circle means running acceleration. You have acceleration in order to running in circle, right?
Right.
And without consuming energy. constantly running without consuming energy. So that make every single atom is a perpetual motion machine. That's just impossible. No matter how you square it. But I will tell you how did I discover this one.
Yes.
So that make things very interesting. If Nate, you know how significant if this is true. If there is no orbiting free electrons, which means there are no orbitals, which is called a quantum principal orbits, principal orbitals around the atoms. So there will be no quantum jump, right? If there's no quantum jump, basically there are no rotation motion, no free motion inside of atoms whatsoever. That's what I discovered. If that's true, what happens? All the quantum mechanics is based on what? Based on the originally electron orbiting certain orbit, now becomes electron clouds, right? It's in motion in the different orbitals in different regions. So that's entire quantum mechanics at stake. If there is no called perpetual motion machine type of atom, there will be no quantum mechanics. And I know lots of physicists that would be very happy about quantum mechanics. That's one of the top, you can say, top 5 mysteries in universe in physics. Say, does quantum mechanics make sense?
Yeah. Now, what about if the idea is that there's no perpetual motion? What about the rotation of orbits and of planets and solar systems and galaxies? All of those rotations, are those also not perpetual?
No, that's not a perpetual. That exists. Just take longer. Very interesting. So if we say, hey, solar system, right, have a rotation, let's say Mercury. If Mercury under external force, say some impact, from outside of the solar system, right? So it's a comet or asteroid, some impact could slightly change its orbit, right? So that's allowed. That's called classical physics.
Okay.
Have nothing to do with quantum mechanics. This is all allowed. Quantum mechanics, assuming the orbit has a certain distance and a fixed orbit, and no, in this case, we are talking about the electron. So no particles like an electron can go through one orbit to another, jump to another orbitals, and increase and jump without going through space and time. It cannot be continuous. Go through the space and the time. So how can it get there? You have to disappear totally. The mass has to disappear, and instantly appear on the other orbital, and with no time difference. And the reason it has required that one is because in order for the first discovered, that's a Niels Bohr. In order for Niels Bohr use this planetary model to fit with a hydrogen spectrum. Hydrogen has a light spectrum. In order, it has to make up. Say, hey, I have to make an orbit certain diameters. Say certain diameter. In order to make the wavelength of that quantum, the principal axis to match a spectrum of hydrogen or something. So you have to fix the distance, fix the angle, fix the fix the length, and then the jumping. You cannot go through the space, so-called be continuous with space-time. If you do that one, the whole quantum structure will be break down. The theory cannot be that one. So that's why in order to make quantum mechanics work, there are a lot of restrictions. Basically, if you try to fit the data, you have a goal, and you want to fit data, eventually you will find a way.
Right.
Change the parameters, change something, make lots of unnecessary restrictions, you will get.
Right. Confirmation bias is a real problem
That's
within
the
research. Yeah.
human.
So this thing brings up a question then. Explain to me, under your theory, what is gravity?
Oh, so gravity is actually a magnetic attraction. So gravity is the summation of a mass system. A mass system possesses what is it? Electromagnetic force, right? So we can say gravity is a summation of the electromagnetic force of a mass system. So gravity is just part of a magnetic attraction. That's a simple answer.
Is there, so in your theory, would it be, is it possible to, this is one of the challenges in space travel, right? Is the concept of how do you create gravity without mass? So is it possible to create, gravity in, say, a spacecraft or something? If you had a powerful enough electromagnetic field.
Oh, yes, because gravity is part of electromagnetic field.
Okay.
In the theory, I will tell you, if you're interested, I'll tell you how do I come out of this conclusion. So that's a very interesting. People will think, did you just one day wake up and you find out that this gravity is part of is a manifestation of a electromagnetic force? No, this is spend a long time. Eventually, nail down, find there is no need for gravity whenever we have an electromagnetic force.
So if in your theory, does electromagnetic force, does it exist because of just mass, or is it because, a lot of people say that our electromagnetic force comes from, the fact that we've got a spinning core, and it's creating, molten core that's creating, this magnetic waves. And there's been some experiments that seem to indicate something to that effect, because there's less magnetic field on, like, for example, Mars, right? Which is why there's no atmosphere.
Right.
So how, if that's the case, well, first of all, is that the case in your opinion? What is causing the electromagnetic field of gravity that we have here on Earth? It's, why aren't we flinging off, this planet? Why are we stuck to it?
Very good question. This you ask one fundamental questions about is electricity. So is that the gravity produced by spin property or by the motion of a electric charge, or the charge created by motion or by magnetic field and the magnetic charge? So you point, you say, when we, current theory believe all the magnetic dipole moment, right, created due to electrical charge spinning or motion, and which I dispute. I said that's not true, because number one, because there is no need for any particle to spin. In order for spin create a magnetic force, we know magnets, you can have a permanent magnets, right? In order to have create a permanent magnetic force, and you have an electron spin, so that spin becomes a perpetual motion machine. Where comes that force? Where comes that energy? No. So what I find is there is no spinning like a crazy in atom or by electron or by nucleus. There is no spinning required, because the magnetic force is apparent, is the natural born with it. So we will find that you have a magnetic field or force everywhere, and we can almost magnetize everything in a magnetic field, which means you have innate magnetic properties for every single particle. However, have anybody seen what a charge looks like? We all know what a magnets look like, right?
Mm-hmm.
Nobody see charge, because the charge, let me tell you what the Uon theory say about the charge. The static electric charge, if we rub the balloon and we can attract,
Right, stick it to our hair.
Electric charge is exactly magnetic force. Dynamic electro field. Dynamic means in that field you can generate electricity, right?
Mm-hmm.
Dynamic electric field is a moving magnetic field. So whenever you have a magnet, if you in what is vibration motion or in whatever motion, you create a moving magnetic field. That's called time varying magnetic field. So this magnetic field in a James Clerk Maxwell equation is defined as electric field. So electric field is actually time varying magnetic field, which equivalent to say a moving magnet. Moving magnet, because you have a moving magnetic field now, will create electric field. So in my language, I can eliminate the word of electric from the whole so electromagnetic first. I can electro and remove part without changing any fundamentals to the theory.
Interesting. All right, let's see what else do we got in here. So going back to black holes, so if the current theory, right, is that there's a supermassive black hole at the center of the Milky Way. And
that's right.
What is this slide telling us here?
Oh, this slide tells a research. If you read the chart on the right, so that research from Cake and the UCLA, a Galactic Center group. So this is a joint research. Spent 20 years observe the center of galaxy, a Milky Way galaxy. They conclude, seems like there are something at the center of galaxy, and all the systems orbiting around. So that's one of the, evidence, experimental evidence. Say, hey, we must have a black hole at the center of a galaxy. So I'm just show you. So we do have an experimental observation. Okay. But does that mean we do have a black hole at the center? That's something we will discuss next. Yeah.
Okay. So if not a black hole, then I'm assuming that it would have to be some sort of very powerful magnet, right?
Very interesting. Very interesting. I'm gonna explain this one if you change the page. So this is somehow I believe this is the artist's impression here. Sure. Because we are part of a Milky Way galaxies, right? So we are on the disk in the same plane. Right. So we cannot right now. There's no object can fly out of the solar system and get the angle of the Milky Way galaxy in this angle, right? So this is an artistic impression, because that's fine. So this basically says at the center of a galaxy, in Milky Way galaxy, we may have a black hole. So that's one image I just show you. If you can move on the next one. And so now I wanted to say, hey, why we have problems with the black hole? The first problem with black hole, actually, it was Albert Einstein. People use his equation, predicted. His equation, he has the equation, but the solutions by somebody else, right? And people use that solution, predict there should have this is called a supermassive black hole at the center of the galaxy. However, Albert Einstein himself does not believe this kind of singularity object should be exist in the real world. It against his philosophical beliefs and also a lack of experimental evidence. So, and actually, the man considered one of the greatest physicists, does not believe there's a black hole himself. So now let's talk about another famous physicist. That's Stephen Hawking. He's the proponent. For the black hole. He did the work with his academic advisor, right? Prove, theoretically should have one. And I wanted to tell you how his opinion has evolved from the earliest year in 60s, early 70s. Mm-hmm. He believed, there's a singularity theorem, so should have a singularity, and the black hole could be a thermodynamic effect. So that's an early belief. What happens in the second phase? That's in 1974. Stephen Hawking created called Hawking radiation. So that's something he found. Okay, if based on the earlier black hole, so black hole can preserve all the informations, right? Black hole cannot only can grow, cannot losing, disappear, right? And now he evolved and said, hey, based on the quantum effect, right? So black hole actually can radiate, can losing energy, losing matter, eventually can dissipate himself. So that's one improvement in his theory in the 70s. And in the third phase, that's in 2014. He made an article. So if you look at it, that's the Nature's article. Says Stephen Hawking said that there's no black hole at all. You see what happens to him from the proponent, one of the founder of a black hole theory, to eventually does not even believe a black hole existence. So that tells a lot about the black hole is true or not.
That's interesting. And we don't hear about that, in the public. I'm sure they're still teaching in all of our public schools about black holes.
That's very interesting. In 2014, I believe that's in April, I attended a American Physical Society annual conference. And I asked when we invited one German physicist talking about the black hole, and as a conference, as a leading lecturer, for that conference, and I asked him, I said, hey, just a few months ago, so that's January, and so January, Steve Hawking said, there's no black hole at all. I said, what's your comment? He just brushed it off. I could not even summarize, because his topic is about the black hole, and he said, "Wow, there's a need 6 times of mass. We're missing 6 times mass, for dark matter.
For a black hole to exist. For
dark matter, we're missing that one. For black hole, it could be billions of times mass. In this case, I believe it's like a 4 million times of solar mass in order to keep a center of the Milky Way galaxy to be to rotate, to be stable, to rotate that way. So this is brushed off, just like you said. So if you wanted to know my discovery, that's what's coming next. I will tell you what truly is.
Okay.
Yes. Okay. This is my analogy. So before show you my answer to black hole, I'm gonna show you this analogy. Have you ever experienced a hurricane season? Nate.
Yep. I lived in Japan for 3 years.
Oh, wonderful. So that will give you first-hand experience to know what is the live through hurricane, and especially go through the center of a storm, the eye of the storm looks like.
Yeah,
I've been here, and so that's if I use this analogy, everybody in Florida, they've been through hurricane, they should understand.
Sure.
What happens hurricane before hurricane arrive and after you passing the eye of storm? What happens? lots of rings, lots of wings, everything pounding, all the house, all the roofs shaking, right? Very, very noisy, and with wet rings. But once you get into the center, get into the eye of a hurricane, you know what happens? There are no wings. There are no rings. If you look through from at the center of the eye, look through this eye hole, look to the sky.
Yeah,
there are no clouds.
Blue, sun, yeah.
Totally blue sun. Yeah, you see blue sun. Totally one color, not even clouds there. And there's another thing. It's so quiet. There are not any noise. There are no noise. You know what happens? Because of huge rotation force. So this is called centrifugal force.
Right.
So any heavy particles, I believe, include the moisture, the water moisture in air. It's all what is it? Called the centrifugal force. All fly out. At the center is purely peace, purely quiet. So you have this experience.
When I was a kid, I remember the merry-go-round. And this was one of the most fascinating things to me as a kid, because I knew if I could get to the center of the merry-go-round, no matter how fast the kids on the outside were spinning it, I could stay, I could stay centered without any problems. But the moment you started moving towards the edge, that force, became much, much stronger until you got to the edge, and then you couldn't hang on and you get flung off. And that's one of the things that has always just confounded me, is that with the Earth spinning, right? Why aren't we flung off the Earth?
Yes. So now, and this phenomena is we can all predict based on the classical Newtonian, mechanics, right?
Right.
And so what happens at the center of the hurricane? There is nothing there.
Right.
All heavy vapor. So this analogy, once you understand this analogy, then you will understand what happens at the center of galaxy and why it's black. Okay. So, and why all the matter can hold together. So I believe now, probably audience could be ready to receive a new understanding about black hole. That's the next page.
Right. Okay. All right. So what are we looking at here?
We are comparing the traditional black hole that's on the left. I labeled as a black hole, and with the Uon Theory. So that's the theory I developed a decade ago, a dozen years ago. So I compare two phenomena. We all observe the same phenomena. However, I want to say what is the traditional way, and what is the Uon Theory's way. If you look at the table, so the first thing is current theory. Talking about that, so gravity governs galactic dynamics. So everything motion is governed by gravity. So that's why we use gravitational theory to calculate the mass. We find that we do not have enough mass to keep the galaxies, keep the star system at the center of the black hole, near the center of the black hole together. We just do not have enough mass. So that's what the current theory says. So what happens? With missing mass, we have to create some called the black hole, create some kind of almost an infinite number, gravity to hold them together. And what Uon Theory says, hey, the interaction between stars at the center of Milky Way galaxy is not a gravity. It's not a gravity interaction. It is an electromagnetic force interact. Nate, do you have any doubt about this conclusion?
Well, it's interesting because there's some other guys that I've spoken to, actually from friend of mine who's an astrophysicist who has been working for a very long time to prove that dark matter doesn't exist. And it sounds like it lines up with what you're saying.
Right.
So,
same phenomenon. Yeah.
And so the question then, for me, I guess, is so in your theory, electromagnetic forces are dominating.
Yes.
Or dominant, I should say. And so that is ultimately what gravity is, electromagnetic force.
Yes. Do you know how much dominating? Quantify. Gravity, electromagnetic, if you have a one charge of electroforce, it equals to 10 to the 36 power of gravity. Or in another way to say, because this is very important. So if one gravity force equal to 0 point, you add 36 zeros behind, and then 1 times electroforce. Does that make sense to you? So that means gravity force is 0 if you compare with electroforce, magnetic force, or strong nuclear force or weak nuclear force, because you have 36 zeros behind the period. So that means 0. So gravity is so insignificant compared with electric force. So that's why if we use Newtonian gravity force calculated the force, we're missing matter. If we switch it to Maxwell's, Maxwell equation, use electric or magnetic force calculated this one, we have a suffice. We do not missing any matter. We can have a 10 to the 36 power times of gravity force. So it's way more than 4 million or 4 billion of sun solar mass, right? So we would be accounted for all the missing matters if we use electromagnetic force. I just want to make sure one thing.
Sure.
You look at the center, near the center of the galaxy, those are all bright out, right? Those all, you see the lights.
Yeah,
so those are plasma, right? Those are suns in thermonuclear explosions created with a plasma. Plasma is a highly charged electromagnetic field, right? So that force equals to 10 to the 36 power higher than gravity. Right? We don't need.
Yeah, and then it does away with, completely removes any need for matter.
Matter, right?
Yeah.
Thank you. I hope you can repeat.
It makes perfect sense to me. Now the question is, with this information and how to, if it rewrites what we've always thought about physics, how can that be applied, in ways that, say, would allow for better transit, better movement, how could we, is there a way to be able to break the force of electromagnetic gravity?
Break the force. Can you use another way to describe your question?
Sure. Okay, so one of the big problems in rocket science is that, getting something off of the planet requires a massive payload of fuel. So if we want to be able to move, off of the planet, with a rocket, is there a way that we could do that with electromagnetic propulsion or something like that?
Wonderful. Yeah, this is basically, you are talking about as anti-gravitational technology. If we now realize the so-called gravity compared with the electromagnetic is 0, right? It's 36 zeros behind. So it's never a thing, for us on Earth, right? Actually, so that means, so how can we do space travel, overcome gravitational, we call the gravitational pole is a part of a magnetic pole. It's a magnetic pole, between particles. It's never ever been the Newtonian called a unidirectional force, right? So
Right.
since the magnetic force has a counterpart, which is it has not only just attraction, it has a repulsion, right?
That's right.
So that means
try to push two magnets together. That's another thing. As a child, you learn these things. I remember trying to force two magnets together when they were turned opposite, right? And I could not do it. And I thought to myself back then, as a child, why can't we, create something that creates that pushes away using magnets. I mean, they do this already with, to a certain degree, right, with electromagnetic trains. With the bullet train in Japan. I've ridden on it. It's amazing. It's so smooth, so fast.
Offset the magnetic attraction, gravitational weight, right? Attraction.
That's right. It removes all that friction.
Yes, frictionless. It's so quiet, right? If you travel at a high speed, if you can travel in vacuum tube, right? So so that create a possibility. Actually, we do have a success examples. Anti-gravity device. If you can reverse gravity, Earth's gravity attraction magnetic body, if you can reverse the force, reverse it, so you can surface becomes weightless, right? However, if you initially you reduce the weight, but if you can truly reverse them so that you create a likely charge repel, what happens? That would be, you would have the same phenomenon on the UFO we observed. If any,
and that's where I was going. That's where I was going with this, because I've known for a long time that if in order for that, there's a couple of major problems, right, with the ideas of UFOs based on our current traditional theory of gravity, and one of the biggest ones is G-force. Anything that's in one of these things is going to get destroyed, at the speeds that these things move at.
Right.
So what you're saying, it leads me to a lot of questions. One, do we already have anti-gravity technology? I mean, there's people currently right now that have been talking to Congress saying that we do. There's people who have said that they've, and that's, they're testifying under oath. So it's one thing when somebody writes a book and just talks about it. It's another thing when somebody goes before Congress and actually says, yes, we have this technology, because now they're under oath and they could actually go to jail for lying. So I have to take it with, a certain amount of respect for what they're saying. But I've wondered about things like, for example, we don't seem to have the technology today to build some of the monolithic, structures that ancient people did in the past.
Right.
It's certainly not within the time period that, that they claim these things were built. And with the exactness, I mean, I'm talking, millimeters with no space in between. And it's unbelievable the kinds of things they've done. And I've often wondered, is it possible that, people in the past had some sort of technology that was able to manipulate gravity?
In my opinion, it could.
I once heard a really great theory on this, and that is that, and there's been a lot of research into this. If you took electronics, for example, today, and and they've done some experiments where they've basically put it under a massive amount of pressure, and they can advance the breakdown of materials, right, over a period of time. And I think it's like within like 1,000 years, it's not, you can't even tell a circuit board. It's like you wouldn't even see it as a circuit board. It would just look like basically biodegradable materials, over a period of time, you wouldn't be able to see it anymore. So the question is it possible that there was advanced civilizations in the past that got wiped out due to some sort of catastrophe? Obviously, I'm talking about and referring to, Atlantean theory and that sort of thing. But one of the things that's fascinating about that is if there was some sort of catastrophe, some sort of, national catastrophe, or, the whole planet was affected by it, the people who survive would not necessarily be the intellectuals or the smart scientists and all of that. It would be those who were hardy, those who were good at survival, And I don't think of a bunch of guys in lab coats as great survivalists. I think of, people who are willing to, willing to hunt, willing to forage, willing to kill. Those are going to be the people that survive, not necessarily the smartest, but the strongest. And so it's possible there may have been some advanced civilizations in the past that got wiped out, and maybe the less intellectual people were the ones that carried on, and they didn't know all this knowledge.
This is a very very likely happened in the past. So there's theoretically, we can, based on the theory I have, say, hey, gravity is nothing, or the weight, or is nothing more, just a magnetic attraction. So the magnetic, you can have a repulsion force. If you can manipulate by somehow, say, instead of pull you together and by repel you at accelerated speed. So that's how observation about the UFOs, right?
Mm-hmm.
UAPs, so they said that you can instantly from 0 to 50,000 miles or something in a second. It instantly happens. So that means you instead of a gravitational force attraction, they reverse it, become anti-gravity, does like pull repel.
And it's not just in the air. I mean, there was documented cases underwater, unidentified submersible objects, and that's even more complicated because you've got water, which
you have a resistance from the water, right?
That's right.
Viscosity, yes.
But if you were able if you were able to push that water away from you,
right?
Creating essentially a vacuum. You could move pretty quickly through it, I would imagine.
Oh, you are right. Create a vacuum behind you. Yes. So that's a vacuum collapsion and create a force too. Yeah. Oh, so this technology. So when we were interviewed lots of UFO or some kind of phenomenon. So I said you do not have to go through high dimension. Many they try to give explanations and use high dimension string theory something to justify. I said well, under class, which is under existing principle, electromagnetic principle, we can explain this logically without the need create new theories.
Now there's a one of the things that I'm trying to find this, I got to look it up real quick here, because I think it was called Brownian motion. Brownian motion, yeah. Which is the random movement of microscopic particles suspended in a fluid caused by collisions of the particles.
Right.
So what are your thoughts about how this electrostatic charge, okay, how it affects, very, very small objects?
First of all, we in order for this theory work, we have to have a medium, right? So we said, hey, objects are made by magnetic particles, right? So these are the source of, people say, hey, motion is natural. Okay, motion, you have to have a source to support it, right? Without a certain force, either will die down, dissipate. So we have to have a this electromagnetic. We have objects, in sky, all stars, Earth, on Earth, even human being, right? Particles, they are objects. However, in order for this series to work, say for us to see light, for us so do a telepathy, the thoughts, communication, over distance or something, you have to have a medium. So when you talking about that, so those are brownie motion or some kind of called a microwave background of the motion, because these are motion. I believe they are all observable, all true, because in the universe is a field with this called the electromagnetic medium.
Okay.
So you are talking about the smallest particle. So what I did, I tried to say, hey, what is the smallest particle? I consider that's the medium, the particle for the medium to transmit light. To light is a wave. For wave to propagate, you need a medium to carry them. So the medium has to be elastic medium in order to vibrate and propagate, right? So,
right.
So that's why. So these. So we know the space is not really empty. It do have a medium, and this.
So
medium,
this is more along the lines of what,
nuclear.
Some of the earlier thoughts about space being ether, right?
Yes, in the old days we call ether, but now I find out the so-called ether, have a negative connotation there. So I would just say it's an electromagnetic field.
Okay.
It's an electromagnetic fluid, or I would say magnetic fluid. So why you mentioned a brownie motion or something? If you have a magnetic fluid, and then you have what? You have light. Light is the vibration of the fluid. So under the background of the space, just a microwave background, they're constant motion, because light is motion. Anything transmitted light, of course you are in motion. So of course this motion, if you're nearby the Earth's magnetic field, you might have, or near sun's magnetic, you will have a concentrated higher density of electromagnetic fluids, right? So of course you would create all kind of basic vibration. That's the basic energy. I hope it makes sense to you.
Yeah, it makes sense. So how do we, I think that all of this is fascinating, but I think what's even more interesting to most people is how do we take that knowledge and use it to advance technology? And so when I think about, in order to create, so let's just say, for example, a UFO, in order to create something that could make a powerful enough anti-gravity device, you're going to need a large source of energy, right? And so where could this energy be derived from to create that?
Oh, it's actually not necessarily you need high energy. Number one, the so-called anti-gravity just try to reverse the magnetic field of the body. Reverse the magnetic field for that small body, right? You do not require lots of power. As long as just reverse it, and what happens? Earth's pulling, becomes Earth's repel. So you can instantly accelerate. So it really does not require a lot of energy, as long as you master how you to reverse the charge, on the device itself. Actually, we do have such kind of device, successful device. We are still testing.
All right. Well, I'm looking forward to that. I think that's that to me is is a fascinating possibility of the future of what we can do. Now, is there are you able to talk about like how, what have you found in your experiments or your experimentation on what's necessary to reverse the polarity?
Oh, that's a great question. So that's something, in order to reverse the polarity of the device itself, right? You don't want to reverse the entire Earth's magnetic field, right? So that's why, yeah. So one, you need to have a high voltage power.
Okay.
another thing is the easiest way, in order to reverse them, you do not want the device will flip easily, and cause accident, right? So you
Right.
need certain rotations. So that's why a UFO, the spherical shape, rotation, axisymmetric geometry makes sense to me, because when you have a rotation, you can stabilize the orientation, right? If you have a disk, you have a spinning rotation disk, and you can stabilize your direction.
Yeah, it's like when you spin a basketball on your finger.
Yes, that's right.
You can basically get it to
You can stay there. That's right.
Or a top, on a tabletop, right?
That's right. Yeah. So you need a spinning, and also the spinning create a rotational electromagnetic field. So that's one of the conditions actually in order for that device to work. So that rotation, and somehow that rotation, yeah. So the rotation, so there's a number one, you have a higher charge, and number two, you have a rotation disk. So it may create some kind of Earth rotation type of force.
Mm-hmm.
And then we do observe, even though the device we have not demonstrated fully reduction of the weight, but we do observe the same device from a different source. They do have videos talking about they can floating in the middle of the air, up to 20 foot in the air, or just on the in the house on the tabletop. They can just from lifting by itself. So it requires electric charge, and also requires some magnets interact with the rotational magnetic field. And the another interesting is it has something to do with ultrasound. The device, people are working. You in order for something, you have to resonate with several things. Yeah, the rotation disk, the rotation created this resonant motion, and the ultrasound and high voltage. Something once you adjust them, once they click, and suddenly the first thing is flip.
Right.
And the second thing, now started lifting, so we
that's interesting, and I'm curious if you have any explanation for this, but it's interesting that both ultrasound and magnets are used in medicine, alternative medicine, but there's a lot of evidence that it has a very positive effect on the body. And there's an interesting study that I just read not too long ago, where they took mice that they had genetically altered them to have diabetes and to have fatty liver disease and other metabolic problems. They applied a magnetic field that was 10 times the magnetic field of the Earth towards these mice, and then they also took a electrostatic charge that was polarized, like basically an up and down motion, and they again 10 times what the Earth's normal static field gives off. And the mice that had the metabolic problems, their livers healed, completely healed.
Yes.
Like it reversed all the metabolic problems that these mice had. The theory behind why they did this experiment was the thought that in nature, like if we were walking around barefoot and we were laying on the ground at night, sleeping on the ground, we're getting, a normal dose of electrostatic, but basically we walk around with shoes that have rubber soles. We're not getting the electrostatic charge, that we normally would get from contact with the Earth. And there's a lot of talk about that now in science with grounding and the importance of grounding in order to, I know this much, that our blood cells, for example, will stick together, and by just applying a little bit of electrostatic charge or discharge, I guess, to our body, you can cause those cells to separate, push away. Certain, enzymatic foods and things like that will do it, but also so does just walking on the ground. So there's a profound force that happens just with the Earth's own natural electrostatic field. So if you increased that, you know, and you harnessed it somehow, you know, those two things, magnets and electrostatic charge, and ultrasound, that's another interesting one too, because there's a lot about harmonics and vibrations that are fascinating. I mean, I've seen it. You know, I play guitar, and I tune my guitar through harmonics. You know, I don't need maybe just to get that first note, I might need a tuner, but I get the rest of the notes by tuning to harmonics. And you can hear when it's not, you know, when it's not harmonic, or when you don't have harmony there, you get this wah wah sound, and you can actually like film it and see, you know, massive waves, you know, on these strings when they're not in tune with one another. Yes. So it's kind of an interesting thing. So there's something going on. Clearly, there's some sort of interaction with harmonics and the space around it, right? So it clearly has an impact and effect on it, because there's also the famous bridge. I don't know if you've ever seen that video, the bridge that basically was being affected by the wind in such a way that it caused just the whole thing to just be, you know, kind of flipping all around. And, you know, a lot of that had to do with the harmonics of the materials that the bridge was made out of and everything.
Right. Something like a Golden Gate Bridge, something, right?
Yeah. And it was
when
just
you
really
hit the harmonics, there's just no way you can prevent their collapse.
Yeah. All right, let's see what else do we got in here. All right, what are we looking at in this slide?
Oh, so this slide basically show we have the latest, you know, called direct image of black hole, right? You know, using called the Event Horizon Telescope. Basically, make an entire Earth as a one lens, right? And use the radio telescope to code the image. So this image, you know, does not violate any of the theory I was proposed. So at the center, you see darkness is not because it has a black hole in it. Black hole. Oh, black hole means you have some black object in it. In Uon theory, because it's absent of matter. So there is it's called black void. There is no matter. So that's why you see dark. So all the observation does not violate any of Uon theory of black hole.
Interesting. All right, let me and you said this light that's on the event or what they call the event horizon is actually plasma, right?
Right. That's you know, the star system near the center, right? Those are huge explosions. Of course, they generate all the lights nearby, so-called event horizon, right? Yeah, and under huge rotation, you know, velocity. Yeah.
Now, have you done any experiments, or have you read about any experiments that have been done with plasma and being able to control and manipulate it? Because what there's a lot of theories, you know, in the UFO world. You know, obviously you've got the flying objects and stuff that are clearly a craft, right? But there's also these orbs of light. And there's a theory by many that these are actually plasma that are used for, you know, some purpose or whatever. What's your thoughts on that? And, you know, how would somebody manipulate plasma in a way to be able to, what do you think that is?
So number one, plasma basically is when it's in plasma state, so it's in all the particles in charged state, right? So it forms a strong electromagnetic field. So that means if you want to manipulate this plasma field, you need to have an electromagnetic field to contain them or to move them. So that's one way, your electromagnetic field, because every charged particle, all the plasmas become charged particle. Charged particle are, you know, are of course are electromagnetic. So that's why you can manipulate. So application, I would think about one. Right now, there's a lot of research in the called fusion research. They use plasma, right? Control plasma, try to focus plasma away from the container walls because they want to create a huge temperature. Tens of millions of degrees, right? And at the center, but if you have a container device, of course this device material will be melting. So they try to use plasma to control electromagnetic field. Use electromagnetic field to contain the plasma. Only focus on the center of the container, does not touch the wall. So that's one of the technologies. So they can create millions of degrees.
Wow. All right, let's see here. We got all right, what are we looking at here?
Oh, this is basically the summary
of everything.
Summary about the Uon theory of everything. So before I touch this summary of Uon everything, I wanted to make one thing clear. So Nate did ask me, so could the impact of the physics, right? So how deep the impact would be, I wanted to tell you, starting from electron. So I find electron model. Electron is actually not a negative charged particle. That discovery of electrons, J.J. Thomson in 1897, defined the electron as a negative charged particle. From that date, once people take that as a fact, so we evolved. We have a negative charged particle electron, and then we discovered a positive charged particle positron, and then we discovered charge zero neutron, and then we made up the solar like a planetary atomic model. It's all based on the single charge. Remember, if electrons are negative, protons are positive, you cannot in contact. If you in contact, create a matter antimatter annihilation. So that means matter disappeared, becomes energy, something like that one. So based on that's all the current theory say, hey, so the atomic model, in order to be stable, you have the constant rotation, So the free orbiting, free electrons orbiting around the nucleus. So because of just one thing, electron we defined as a negative charge particle, that started entire physics up to date. So that's what have the best and the greatest theory called the standard model of particle physics. It's all built on the single charged particle. And in order to keep them stable, so we created this model. So now, since I convinced and I demonstrated, electron cannot be a single charged particle. It is actually just a magnetic particle, just a magnet. You can just simply say, just a magnet. Once you realize them, so all the atoms, you do not have I just want you to look at all the atoms.
Okay.
Just like this one, or you can say even electrons. Electron made by even smaller particle, I would call it Uon, so the fundamental particles, are made by magnets. So there is no motion required. So that means what that means? That means anything related. When you every time mention electron and as a negative charged particle, all those languages and all the theories based on that one has to be fundamentally changed.
So how does that impact? You mentioned chemistry earlier, right?
Yes.
So reactive chemistry, they claim that you've got something that's stealing an electron from another atom, right? So explain to me how that would change all of that.
Actually the first confirmation I got based on the model is based on the compare with chemistry. Okay. And it is 100%. Surprisingly, it's 100% called recreate all the chemical component structures which contradict to quantum mechanical model with chemistry, and I can recreate them. And during the process, I made several solved several mysteries in chemistry. Say why proton is 1836 times of heavier than electron. However, proton and the electron carry identical charge, right? All single charge. However, one is super over 2,000 heavier than you. Why they they both have a similar charge? Of course, opposite, so-called opposite. So I can explain that one. I solved that problem. And another problem is about forming forming lots of so if I can show you something about it. Yeah, if you can I don't know if you can see this one.
Here,
yeah.
let me blow up your screen.
Yeah, you blow up that one. So
let's see here.
Yeah.
Okay.
Yeah, I hope you can see the. So this is try to explain why proton and the neutron is almost 2,000 heavier than the electron. Why they have equal charge, right? So I solved that one, and another one is, do I have them printed here? Oh, water molecule. Water molecule has a certain angles because the water molecules H2O, right? The two H's, it has to fix at a certain location to have 105 degrees, different angle. Why it is that? I have them. Maybe next time we can talk about how this one 100% predict the chemical structure and chemical model without involve any orbiting electrons. That's total. You look at so ridiculous. How can you even molecules, even hydrogen molecule, you have two electrons, from each atom, right? You have to binding them to form molecules. We were told that the electrons are orbiting.
That is true. Yeah. How would they bind, right?
You have to orbit at a certain velocity. Otherwise, it can be matter and the matter will disappear. It's called annihilated, right? Yeah. How can you fix that one? So that does not make any sense. But use this theory, it can easily to explain, molecules, water molecules problems. Oh my goodness! I have a list of the mystery, has been solved in chemistry. All the rules in chemistry. So without that, how the chemistry, those rules are working. And there's another interesting concept. Without the rotating, free orbiting, those called the electron, how can we explain electricity? Yeah. People ask, where the electron got the energy, right? We have called the charge. We call the electricity is a flow of electrons, right? Right. That's what I find that is there are no particle whatever traveling in a solid metallic wire whatsoever when you have electricity. It's all about the vibration. The particles' vibrations is a wave motion.
Is it traveling around it?
The propagates is not there are no particle traveling around a wire. So we have electricity, right? Electricity is generated by rotating. You have a rotating magnet, the moving magnetic field, right? Create the particle oscillation. Right. Create a particle also not create a particle ladder, translated motion. It's created when you use those arm, you make the turns. You create the oscillations, vibration particle, and those particles vibrate and propagates. And this propagation is the same as light propagates from ether. We call the magnetic field, right? Whenever you have a magnetic field, one property about the magnetic field is it is elastic. Means if one particle rotates, you will make the other particle rotate with you. gradually. And why light can propagate almost infinite distance, right? That's because they oscillate at the natural frequency of the medium. So then, as long as you have a small input, you hit the resonance frequency, and the light wave will keep propagates.
So if you wanted to propagate a magnetic field and you had the right frequency of whatever that object is,
that's the source. Yeah,
right.
If you have a frequency, another source, right at the same natural frequency as the propagation of light waves, then the wave can keep propagates until the source vibration stopped, and then wave die down. Right. Does that make sense?
That makes sense. Now, is that how could that have been used in this theory? Could that have been used to say move large objects like massive stones?
Yes. Right. I believe so. That's why natural frequency, if you apply external electromagnetic fields, hit the natural frequency of object, now you can move the object. I do believe so.
It's interesting because there's some archaeological findings of ancient Greeks having massive batteries, chemical batteries, and in these big clay cylindrical objects, and nobody's really been able to explain why they made these things. Maybe they made them because they had some knowledge about some sort of electromagnetic ability to do something with them. It's interesting.
Yes. I think
now, I've got to ask, because there's been some talk lately. There's been some interesting things that have been coming out. There was I can't remember the name of the guy, but there's somebody who's tied to the Trump administration talking about and admitting to some technology that we've had that has to do with teleportation and and time travel. What are your thoughts on that, and does this have any application towards those things?
Oh, okay. Yeah, that's something, number one, I do not that the manipulation is changing the space and the time. I don't believe that, but it can changing the perception.
Right.
And could make an object, right?
Well, that's what I've heard said is that it's not that you're really traveling in time. It's that you may slow down processes of your aging, or that your experience of time. So in other words, you might be able to kind of leapfrog forward in your own experience, but there's no such thing as going backwards in time. You can't.
No, that's something I don't believe either. Yeah.
And so it may be a perception of, going forward into the future, but you're not going to be. The reality is that you are essentially changing your experience and your process of aging and everything else. So I don't know. It's interesting.
I do have one theory about why he declared this one publicly, right? Mm-hmm. If you truly mastered, you can manipulate the space and time. Do you want your rivalry, your arch enemy? No. That becomes the leak of the secrets, right?
Right.
so these are smart people. Actually, he used to be work for Peter Thiel, so mm-hmm. we have a lot of contact with them. So these are smart people. I believe could be like a Cold War tactic. Right?
I understand what you're saying.
Okay.
That's all. I totally understand what you're saying. Yeah. No, I get it. I definitely think there's some truth to that. This is very fascinating. I think the application, especially in the area of movement, transportation, in the area of medicine, I think is especially chemistry, right? If everything we know about chemistry is wrong, and we were to apply this new framework,
Yes.
what would it allow us to do? Like what kind of energy could we develop? Like would we have, like right now, a lot of the energy that we produce through fossil fuels, for example, we lose a lot. There's a lot of wasted energy. And so could we, create energy that, obviously you're not going to have perpetual energy, but you could get pretty dang close.
Yeah.
And have, energy that is far more sustainable with a lot less material used.
One way is to use electromagnetic launcher.
Like electromagnetic what?
A launcher. So launch rocket instead of use chemical propellant, right? Consuming like 95% of all the chemistry, fuel used to lift up the small or less than 5% of a mass into space. It's a totally waste, right?
Yeah.
If you use the electromagnetic launcher, then you don't need all those fuels. Just that little capsules, right? Just lift a little capsule, just like a shooting. I believe it's just.
Well, wasn't that kind of the idea behind the electromagnetic railgun?
Yeah,
railgun.
Yeah.
Now I know, like there was a lot of. I remember I thought I read something about that they were discontinuing, the use of it or the research on it. Do you know why that is?
Oh, I believe one is a safety issue.
Okay.
Under strong electromagnetic field, right? Biologically, if you can tolerate.
Well, and they were also, this was being used a lot with the U.S. Navy. So you got a big metal ship on the water. It just doesn't really sound like a great idea using electromagnetic energy in that way. That might be a problem. So
anti-gravity technology probably is easier way to go.
Yeah, I think so.
You can gradually accelerate, right? You don't have to reverse it right away, right? Gradually make a launching slow, start with losing weight gradually and started the acceleration to lift off. I believe that will be one of the most important application for this Uon theory. Since gravity is no longer unidirectional force, so we can reverse the charge of just for the particle, for the, say, crew capsules, right? Just reverse the force of the capsules, and then it can create a, ascent force.
I've got another question for you, and if you get tired and you're ready to call it quits, I'm going to keep asking questions because I've got just so many of them. But I've got another one. With your theory, how is lightning explained?
Oh wow, that's good questions. This is related to what's called the Nikola Tesla, so how to use energy. We have a natural voltage between the ionosphere and the Earth. We call the zero charge, right?
Mm-hmm.
So between them, so we have a huge potential charge difference, right? So that's where lightning comes from. So lightning may not, this charge may not enough to penetrating entire the atmosphere. However, if you have if you during the raining time, the water becomes conducting material, right? Or the clouds, the moisture of clouds becomes conducting material. So now you create a lightning.
Now you have a path.
That's the path.
You have a medium.
Now you create a path. And then you create the lightning. That's a huge force. I believe that's the force. maybe Nicholas Tesla may mention about can be used for military purpose, can shooting down airplanes.
Yeah.
Or
directed
you can
energy weapons,
purpose, right? Build a huge tower and collect that charge. So then you just need to build something like a mask, right? And then you can receive those energy instead of a ground and the 2 floor. You can use that energy.
See, I've often thought like maybe UFOs were utilizing some sort of Tesla coil to basically gather ions out of the atmosphere for purposes of propulsion.
One of the element, I'm not saying requirement, for make a UFO, the device work involved this Tesla coil. Because the Tesla coil also generates its own resonance frequency. So in order for them work, Tesla coil's resonance frequency with a rotating magnets, rotating plates and magnets frequency,
right,
and ultrasonic frequency. Once they are all resonant at the moment, you will see the device.
I can't wait.
Just 1 second.
Sure. Wow, folks, this has been pretty interesting. I want to open up the questions, and you guys have been very gracious and been, asking a lot of questions. And so I want to go ahead and get to some of your questions that you guys have in the comments here. And so if you have a question, go ahead and ask it. I'm not going to go back and try to find all of them because there's been a lot of comments. But if you have a question, go ahead and ask, and I will pass that on here to the great doctor. So while I'm waiting for the chat to light up here, we've got about 16, almost 1,700 people live watching. That are obviously fascinated by this topic as well.
Almost 11 o'clock.
I know, but only on the East Coast. So, yeah, we get people from all over. Actually, I even have people from other countries even that will watch the show. So let's go back to this, the Uon theory of everything. So walk us through this chart here that we got up on the screen.
Oh, okay. So if you look at this Uon theory of everything, if you look at the circle, the central circle, oh my goodness, UON, the N, somehow they change.
Yeah, that's okay. It's probably because I'm using Google Slides rather than PowerPoint.
Oh, okay.
That's probably why.
Changing format a little bit.
Yeah,
okay, that's fine. So the so-called Uon is the fundamental particle. Okay. It's actually just a magnetic particle. Okay. One thing about a magnetic particle is it can infinitely divide. You divide the magnets. You get 2 smaller magnets, right? So you can infinitely divide, you get the same physical properties. So that's what I finally find out. The smallest particle, it has to magnetic particle. Because only divide the particle, small particle, you can unify them, combine them back to bigger particle, right? So if you divide it, then they cannot coming back together. So then the universe will not work because all the particles has to combine each other. That particle binding force, one thing is it's not gravity force. 2 particle binding cannot use gravity force, right? It's a magnetic force because that's 10 to the 36 power higher than gravity force. So gravity force will not keep 2 particles together. So that's gravity force. And so
and that makes sense. That makes sense for how, even any object, including our own bodies, have to be bound by something, right?
Yes. And what are the force? It's all magnetic force. Besides, this is a fundamental force. besides this one, there are no other fundamental forces needed. We are talking about the magnetic force, which included electric force. Electric force, I said the static electric force, just magnetic force. Dynamic magnetic force is moving magnet. So that's one. So we get rid of them. And what about the strong force and weak nuclear force? The current theory talking about the electron and the proton are opposite charge. Say electron and the positron are opposite charge. They are cannot in contact, right? But if you understand every single particles are magnetic particles, there are no single charged particle. What happens to nucleus? They're naturally attracted. That means we do not need a strong force which opposite to counterbalance our electrical repulsion force, right? We don't need a strong force. Does that make sense to you, Nate?
Yeah, it does.
So that's why if we get rid of quantum mechanics, we only need one fundamental force, just a magnetic force. And the moving magnetic force create the electrical field. So that's why I created electricity, right? And also, since we do not have a single charged particle, so we do not have a like pole repel. You may say, hey, if I have two magnets could have a like pole repel, right? But what happens when they are closer? Magnetic force create a moment, will rotate the other part and then attract. So eventually end up all the matters, all the particles inside of a nucleus, they are attract each other through magnetic force. So we do not need strong force. And also we do not need a weak nuclear force. Weak nuclear force has to overcome strong force repulsion, right? Compression, right? Something. So because if particles somehow under influence of external force or just say you bump it somewhere and some particle suddenly rotate to like charge repel, then you will have an ejection of particles through nucleus. So weak nuclear force is just magnetic repulsion.
All right. So what is with this theory or framework, how do you see things with, and this is gonna, we're getting a little bit more into the metaphysical stuff here, because I've got questions about that as well. Is there any explanation for the concept of consciousness?
Sure.
And there's a lot of, I think there's plenty of evidence that, like take, for example, quantum entanglement, right? The theory of quantum entanglement, right? There has to be some sort of connection, right? Between, even my consciousness and somebody else's on the other side of the planet.
That's right.
This makes sense to me because you actually have this medium, right? Which exists everywhere.
Carrying your thoughts. Thoughts is an electromagnetic vibration, right?
Right.
So this medium transmit your thought frequency, thoughts, particular, message, which is the same as Voyager 1 and Voyager 2 right now.
Right.
They both are outside of the solar system, right?
Right.
And we can still receive their information. We still have control, communicate with them. We use the same electromagnetic field.
Right. How does this influence your perspective on the existence of a divine entity or God?
Oh wow, that's deep. Okay. One thing I would tell you, after I discovered, universe is not space are not empty, actually filled with this fundamental electromagnetic fluids, right? I call it simply magnetic fluids. And I call these are the fundamental form of the universe. So I'm no longer really worried about the past life. I said, eventually we can be back to the fundamental state of the matter.
Mm-hmm. See, that's kind of like,
particle.
yeah, I kind of think the same thing too, that the
Wow.
the goal, right, or the idea is unifying back, right? It's becoming one again.
Yes.
And I think that's ultimately, you know, even within, and I'm a Christian, but I look at like there's the stuff that we need just to kind of basically understand and live. And I think that's what Jesus mostly taught to most people. But I think there were deeper things that he taught to his disciples. And it's interesting to me because there's a lot of things that seem to indicate that, you know, the goal is to become one with God again. And that is the ideal harmony, you know, the ideal solution. That what we're experiencing right now and everything being all separated out and everything, you know, and even the concept of the self, right? The concept of my own individualness, that is, in a sense, something that is not as desirable as being, you know, not myself and being one with the source. And and so I've thought about this a lot, and I'm curious. So I always, you know, and I'll admit, you know, I've had my own experiences in life from a spiritual perspective that have led me to believe without any doubt that there is some sort of God, there is some sort of master creator of all of this that is benevolent and does care about, you know, does care about us. And I think we have some sort of connection to, I think every human being has a connection to that.
Yes, you know, my understanding, let me give you my understanding.
Sure.
Is that, number one, we said we are all connected. Everybody can feel. When, you know, connected through what? Consciousness, brainwave, it's all contained in yourself. Actually, it's through this electromagnetic field. I'm talking about this electromagnetic field. So I believe if a human die, not only their fundamental particle matter, called the matter, is a measure of a substance, right? Matter will not disappear, will be just show different forms, right? So the smallest form is Uon particles, right? So that's one way. Another one, at the human level, the salts, I believe the salts, anytime probably in the history, anyone generate the salt, I believe this salts could still stored in the electromagnetic, in this magnetic field.
Sure. It's kind of, it's ironic because my field of expertise is cybersecurity, and I've been working in it for 27 years, and I've watched it evolve, and now everything is moving to the cloud. You know, and so the way we access things today, you know, I'm sitting, we're talking right now.
It's all existed somewhere, stored somewhere. Yeah.
Yeah, but this software platform that we're using, it's in the cloud. You know, it's not, it's represented on my computer, but ultimately all of the processing is going on in the cloud for it. And so I have to think about that, and I think about what you're talking about with this material, right? You know, the whatever this magnetic, you know, Uons, you know, are moving on, or moving through, or light moves through, that it's kind of like the same thing. And so there is that source, right? I think that, you know, exists up above. There's an interesting saying again, and you know, this is getting a little more on the philosophical side of things, but there's this famous quote by I think it was Hermes Trismegistus, right? Which was as above, so below.
Yeah. Yes.
Yeah, and Jesus.
Hermetic principles. Yes.
Right.
Okay.
And Jesus had a similar saying: "What you bind on earth will be bound in heaven. What you loose on earth will be loosed in heaven." I think they were speaking of the same thing, which is this concept of, you know, that there is a macrocosm, you know, and a microcosm. We are part of this, you know, what we see and perceive in our existence right now, but that our consciousness is actually, you know, it's projected into us, but it's it's actually existing in, in the the cosmos, or whatever you want to call it, heaven. So it's fascinating to me. So I do think that there are mysteries that I think will challenge, as we start to study these things. They're going to challenge our perceptions of not just science, but also maybe even philosophy and religion.
Yes, exactly.
And I think that ultimately is probably why there has not been more acceptance, and more willingness to explore, because I think there's a lot at stake for a lot of people who have placed everything in their entire career into some of these other theories. There's a friend of mine. I don't know if you know him. His name is Alex Mayer. He's a astrophysicist, and he's been doing a lot of research into putting, like, he's got just some massive computations that are going on in where he's like putting all of the known star charts in, and he's come to the same conclusion: there is no such thing as dark matter. It doesn't exist.
Oh, okay.
So I want to connect him with you, because I think you guys would have a lot of very interesting discussions, and I'm sure there's a lot of others that. So I think the way he came to his conclusions was different than how you came to yours, but the same. You both came to the same conclusion by looking at different things, and so I'd be fascinated to get the two of you together to talk, because I think there's some really amazing things that are coming, and but hopefully we can overcome the bias that is in the system right now, and that exists right now. I look at, like, I wish that we were more about the scientific method when it comes to research and all of that, empirical data. These things I think are important. I think we've gotten away from that. I think I look at medicine, and it seems to me like what we saw happen with COVID, that there was a lot less science and a lot more marketing and money making that was driving decisions that were being made. It seems to me that in the world of science, especially like you think about climate science, there's a lot of not really scientific stuff that has been pushing some of these ideas. And it seems to me that the danger in research within the scientific fields is that if the government provides a grant, then they expect a certain outcome. And so scientists oftentimes will drive research in a way to produce an outcome that they see will get them more money coming in from grants. Have you seen this in your field?
For me personally, I'm at work for NASA. For me, NASA is the best place to work, in my lifetime. So I do not, involve. I do not involve with a lot of politics or something. Here is treat everybody with respect, decency, and allowed us to express freely. And but I do want to make a disclaimer. All the views and opinions expressed here are my own, right? Does not reflect those of my.
Well, the joke, right? Of course, the joke about what NASA stands for, right? Never a straight answer.
I hope we can change that perception.
Well, I'll tell you, I am very impressed by your openness and willingness to explore and talk about these things. I used to work at the FBI building across the street from NASA headquarters.
Wow!
And
DC.
I went over at Patriots Plaza, and I remember, and oftentimes you guys would have events that were going on over there, and I would go and and participate in some of them. One of them was the oh gosh, what was it? I can't remember the name of it, but it was the when they sent the, I can't remember which one it was, but when it went into, they crashed an orbiter into Saturn, and so they went into the rings of Saturn. I was there for that event for the countdown on all that. That was pretty cool to watch that, because it was going on while I was working at the bureau, which is between, I think, 2016 to 2017, somewhere in there.
You watch real time.
Yeah, that was awesome. And I mean, I find it fascinating. I've had a lot of questions about, where do we go from here, as a country. NASA has seen, major cutbacks in their funding and stuff like that. We've seen the, kind of shuttering of the shuttle program. And so what is the next steps, do you think, for, what we do? And I didn't even know that they had scientists like yourself doing these kinds of research, in NASA, but I think that's awesome. I think we need to be doing more of that kind of stuff, and challenging, the status quo, because I do think that the United States has the framework, at least, to be the greatest nation on the face of the planet. Our Constitution, I think, is the best thing that human beings have ever come up with to protect our freedoms. And we got a lot of challengers out there in the world. And I think we've got to keep our technological edge, and I think we have to keep our we've got to keep that spirit alive of discovery and advancement. And I would personally love to see, us move and spend, the kind of money that think about, like, how much money we've spent on war in the last, I don't know, 100 years or last 50 years. It's massive, right? I'd like to see us get something, find a way to spend some of our money on some things that actually can better people's lives, increase our health, make it, so that I don't have to travel 2 hours to get to Washington, D.C. I'd like to be able to get in my flying car, go to sleep, press a button, and be there, shortly, or open up my newspaper, and next thing you know, I'm there. That's what I look forward to, is the world of that. But to get that, we've got to spend more of our science and more of our time and our energy and our resources on researching this sort of thing. And instead of, developing, I understand the importance for military as well. I've worked for the military for most of my career. But I think it would be great if we could solve some of our health problems and some of our transportation problems and energy problems, right? We need massive amounts of energy for the future. I'm looking at AI, and AI just has so many amazing, capabilities, to really make life a lot easier. And a lot of people are afraid of it. I'm less afraid of it. I'm more afraid that, we won't keep up with other countries. I want to see us, advance and have the best of the best. So.
Wow. We really need a lot of hosts of people like you, passionate for humanity, right?
Yeah.
Yes.
Well, I think the problem is that we have to have an ability to challenge things and question things, and I'm glad that you're doing that, because honestly, I had no idea that NASA produced such great scientists. This is wonderful. I'm really excited about what you're doing, and I'm going to be following you. And so let's talk about that. Where can people follow your work, and where can they connect with you?
If you can turn another page.
Mm-hmm.
Yes. I'm the co-host of Neighbor's Choice. So that's a website, that's a podcast, special program called Science and You. Oh my goodness, the U, the change format of the U disappeared almost. Yeah. Right. And so I'm a co-host of that program. So I have a great partner. So that's David Gnorski. And if you look, so he has made a lot of interview with me, and also we co-interview with other famous scientists, physicists. And if you're looking for more information, you can visit called aneighborschoice.com. So
neighborschoice.com. Definitely going to be following
yeah.
that. That's great.
You can find more information, more videos on that one.
And so right now with the research that you've done, what's the next step? What are your plans for this next year, and what are you working on at the moment?
I'm still full-time NASA employee, right? We still try to finish the supporting International Space Station by sending astronaut back and forth from International Space Station. So we still have a task to do. And personally, so in science is my passion. So I wanted to make some complete some books and try to make more let more people understand how important, if we realize that the universe is actually not what we told, that complicated.
Well, I think you need to be I think you need to invent the electromagnetic launcher. That's going to be that'll be your next contribution to to NASA. You need to get with Elon Musk and help them develop that.
That's right. As long as we have the power, of course, we need to have a safety, right? We are not gonna overpower, so make an astronaut, get some kind of side effect with the. Yes, I like your idea. Maybe that's something we should do. So instead of make almost 95 or even more % of entire weight, right? Just send 5 or 7 humans, just throw them into space or something. It's a wasting with chemical propulsion system, and if we use electromagnetic propulsion system, and I believe future will be much cheaper, more efficient. And
do you think there's an application that's on the horizon for how we can develop better, more efficient sources of energy?
Yes, of course.
Because I think that's going to be the biggest need I think we have right now moving forward. We have so much technological advancement that's going on with AI and data centers and stuff like that. We're going to need better sources of energy. And I know a lot of people are I'm all for any form of energy that we can get, but I think we've got to find ways of increasing the output so that we can do some great things.
You heard it called a low energy nuclear reaction. Have you heard of that one, Lanner?
No, I haven't. I'm gonna have to check that out.
Yeah, that's a whole group. So they also want to invite me about talking about how to generate create energy without using current fusion type of theory, which I believe the fusion theory is misguided. Without fundamental understanding the nuclear force and how the force created. And so we use the current model of fusion will only increase temperature and make it more difficult for any device to survive just by maintaining high temperature. I believe that's misguided. However,
well, not to mention, as much as everybody talks about how safe nuclear energy is, I lived through the Japan nuclear meltdown. I was living there at the time that we had the tsunami, and granted, that was an older reactor, and there was a lot of problems with the way that rods were stored out in the open in pools and all kinds of issues. But nonetheless, I do believe that safety is incredibly important, and so we've got to be safe with the way that we do things. But I think that there are some great opportunities if people will explore the Uon Theory and explore these different ways of producing energy without as much friction and things like that. I know I know that there was one guy I was talking to that had developed some very powerful generators that utilize electromagnetic force to, that manipulates those generators in a certain way that they're producing, a lot more energy off of a lot less. So I think this will be an interesting future that we have ahead of us.
That's the right direction to go. We have the natural electrical energy resource. We are under the huge differential, voltages once we live on the Earth, right?
Mm-hmm.
We have a ground is zero, say the zero voltage relative to ionosphere with huge electro potentials there. So
yeah,
it's like a lightning, right? If we can use that kind of power, that's always existed, at least, as long as the Earth exists in this condition. So that's untapped infinite energy. So that I believe that's what Nikola Tesla build what is it? Build this antenna.
Oh yeah, big old Tesla tower. Yeah, where he was generating power for that town.
They just tap the natural power. You don't need to create a new one, right? There's a huge potential to that.
Yeah. Well, I want to thank you so much for coming on the show, and man, we've been on here for over 2 hours, and it's been a wonderful discussion. We've got almost 1,800 people live watching.
Wow!
And so I want to ask you. I always ask my guest, what is we talked about a lot of things, but what's the most important thing that you want people who are watching the show right now to take away from this conversation?
Oh, I want, number one, I want people just like me want to thoroughly understand that the universe we lived once. For me, a touching moment is when I over 50 or 50 years old or almost something. I feel like I spent over 2 decades time on learning physics. I actually don't really understand how universe works.
Right. I understand.
So my goal at that time is I just want to understand how my own mother universe works. Before I leaving the Earth, if somebody ask me in another place, say, where you come from, I cannot even explain where I came from and how things work. I feel very sad. So for that one, since I developed this theory, I satisfy myself. I start to have peace with myself. Changing my temper, I changing my behavior, and changing my thoughts too.
That's great. Well, I tell you, I turned 50 this year, so.
You are way younger.
Well, I had it has been it's funny what you mentioned though about how you realize just how little we actually know, and just how much of our life is spent. Like I think about how much of my life was spent on fruitless pursuits, and now I want this, this next half of my life to be, about trying to do something more than just work my, day job and, and survive, right? Because I feel like for a lot of folks, life is about survival, but I think it's about so much more than that.
Yeah, we lost it in just make livings and something, and lost. But in many cases, if we can create energy much cheaper or even free energy with a tabletop, the low energy nuclear reaction type of device on tabletop generate infinite energy, I believe a human doesn't have to work like this one, 8 hours and with 5 days a week. I hope that's the future.
Yeah, I hope so too. Well, I always I always close my show out in prayer. Like I said, I'm a Christian, I believe in God, and to me, it's about humbling myself and recognizing that I've got to do my part, but I also recognize that I need a little bit of help from from the man upstairs. So I'm going to do that real quick and just close this in prayer. Heavenly Father, I just thank you for Dr. Yu and for the wonderful information that he's brought to us today. I thank you, Lord, for discovery and for giving us minds that are capable of investigating and scientific inquiry. And I pray that you would open up the doors within our world of science, especially here in our country, Lord, that you would bring a new revival of scientific inquiry, and that we would see advancements happen that we've never seen in the last 100 years. Just amazing things happening that would better all of society and better our world. We just thank you for giving us these creative minds and giving us the ability to reflect and to reason. We pray that you would bless our endeavors in your name. Amen.
Amen.
All right. Well, folks, thank you so much for joining the show. Remember to like and subscribe, and go and check out aneighborschoice.com. And I think this is going to be just an amazing, amazing to watch and see what's going on, with you and the discoveries that you keep, coming up with. So I think it's awesome. And I'm going to talk with you later and try to connect you with my friend, Alex Mayer, because I've been trying to get him on the show, but he loves, he was down in, I think he was planning on going to Antarctica or something like that. So I don't know where he is right now. He might be down in Argentina or something, but I got to get in touch with him and find out, because he's done a lot of research into mapping, all the known stars, and basically making his proof that dark or antimatter doesn't exist. So so anyways, well, thank you so much for coming on the show, and I really do mean it. God bless you and your endeavor and the work that you're doing. I think it's so important, and I thank you for giving all of us so much of your time this evening. And you have a wonderful day, have a wonderful year, and may you have a lot more discoveries to make.
It's my honor to be on your show.
Folks, stay engaged and stay interested. Stay curious. I think that we've been given these amazing minds, and it's good for us to use them. So, with that said, have a great night, and God bless you all.
Raise some Cain. You gotta raise some Cain. In the heartland where the faith runs strong, we've seen the shadows growing long. Watch those around us be deceived. Yeah, the fight is at our doors, no matter who we believe. Corruption, lawless, day and night, we'll speak the truth into the light. We'll bring the battle, heed the call, watch the whole thing fall. We gotta raise some Cain, show the lies, break some chains and make things right. Feel the power, be the change, time is now. We gotta raise some Cain.